Hello, everyone. I'm Fanhai Lu, Tech Director at Contextual AI. So today I'm going to share the insight how we accelerate the SFT, RL, inference in context layer. First, I want to give an introduction about my company, Contextual AI. If we see this diagram, right, in the bottom side is data source. This is a massive volume of a complex document. And in the upside is application layer. It could be chat, agent, or could be something like custom app or workflow. Our company, Contextual AI, we are sitting in the middle, the context layer. We do all the heavy work from the query execution, agentic search, and data management side. So for the business, right, before they can build this application, chat, agent with DIY solution, but it's very complex, it's hard to scale, it's not production ready, or it could have a lot of bugs. With Contextual AI solution, the business can build the enterprise AI. First, it will something like production grade, you will build much faster and it's scalable. So this slide, I want to share some use case. So this is the real use case. The first use case is about the domain-specific knowledge assistant. So those include with QA or chatbot. The second one is device log analysis. So with our log analysis, we can reduce the debug the root cause error from weeks to minutes. So the third one is about we can also generate the test code. This is especially critical for semiconductor testing and validation. Also right now, a lot of workflow, they are dynamic and very complex. So we do have the dynamic agent orchestration there. So a lot of enterprise or business, they want the structured output. So we can turn any document to structured output. What makes our company different, right? We have a very good research team. We are heavy on the research, and our research team, we are working very closely with the platform, infra team, and CME, and also sales team. So I share few achievements our research team did recently. The first one is our Llama GM model. We are #1 ranking in FatGround leaderboard. LM unit is neutral language unit test. We are #1 on the reward bench for generative models. If you see the chart, right, the overall we are ranking #2. So the top one is something like called sequence classifier. So, but in the real case, our generative model will be better than the sequence classifier. I can go a little detail. So when people do the sequence classifier, right, you only have one scalar value. So make sure, okay, this is good or not a classifier. From our ML unit, right, we did more rich feature and generate more output. The first output we generate is a reasoning token. So it's reasoning that, okay, good, bad, or neutral, all those things. The second one is continuous score. This is scalar value. And also we have the third one. So this will also, we can also do the preference check. So which one would be better? So when we do the training, right, we use this is the 3 different loss. For this is the reasoning token, right, we use cross entropy loss. For this is the score, continuous score, we use the MSE loss. And for the preference, right, we use the pretty famous the Bradley-Terry loss. So with that, right, our LR unit is performed well in the real use case. In Contextual AI, we love open source and we use open source. Also, we contribute to open source. So our re-rank V1, we are first instruction re-ranker. For the V2, right, we even do next step. So we purely push this to the open source. When we do the re-rank V2, we balance the accuracy and also efficiency. Yeah, for the next few slides, we'll focus on how we do SFT, IL, and inference. So in Contextual AI, for the re-ranking model, for generation model, we leverage the supervised fine-tuning to tune those models. But for the more complex, like planning model, how to use tools, we leverage IL training. In the end, right, doesn't matter which model we need to serve in the production because our customers are really business and enterprise. So on the different areas, the challenges are different. I will talk one by one. On the SFT side, first is the data. So we need a high quality data to do the SFT. And another one is the training optimization. Even the framework is very stable right now, but still there's a lot of way you can do the training optimization. In the end, we want our training to be much faster and also low cost. Eval side, we wanted the eval to be stable and also accuracy. From the reinforcement learning side, the story will be different. First is have a very complex data flow. The rollout training, and also you have different model, ranking model, policy model, critical model, all those things, even reward model. And also since Contextual AI, right, we do a lot of tool usage and also multiple terms. This adds another challenge. At that time, especially early this year, the infra is not stable. Either IL infra or the tool usage infra not stable. When we do the training, right, they could have the reward collapse. Especially right now, we push more tokens there, right? The long context. What happens if 100K, even we push 1 million? So this was the challenge on the IL side. So go to the inference side. We did do serve a lot of models. So there's a variety of models based on the model type. Vision language model, encoder model, reward model, all those models, all the size. We have a 1 billion model. We even have a large model from to the 1 trillion. Since we are serving our customer, we are very sensitive on the latency side. We want a very low latency. Also, the traffic could be spike. We don't know what time. It could be sudden spike. The spike traffic could be 10x than the normal average traffic. Reliability is also another challenge. We want our inference server to at least 3.9. It's good to have the 5.9 reliability. Also, GPU chips is very costly. We want to be the resource efficient. Yeah, for the next few slides, I will go to this challenge area one by one, see how we did from Contextual AI. First, on the data side, right, the industry right now, either you do the human label data or you do the synthetic data. Both have the pros and cons. Let's first go to the human label data, right? Yeah, human label data, we can find the domain expertise there. They can really understand the use case, the real world, the coverage, and the distribution. We can fully trust them, use them as golden standard evaluation. But meanwhile, those domain expertise, either you hire contract in your company or you with third vendor. It's very costly. Also, humans do this label rule by rule. It's time consuming. And also, we are human beings, right? We know humans sometimes is biased. And also very hard to scale. It's very hard to find 10,000 expertise for a certain domain. On the synthetic data side, right? So there are also pros and cons. Synthetic data side is very easy to scale. As long as you have the cheap resource, you can scale the synthetic data. And also you can rapid iteration because it's your control, the research and engineer control this synthetic data. And this is good. You control the recipe, you control the pipeline, you control the model. But also have cons, right? The synthetic data, if you not design well the distribution, like large gap to the real world. And also have the capacity setting, right? If could be setting by your models or could be recipe, could be some bug in the pipeline. And of course, in the end, if you want the synthetic data working, you need a large effort for the, especially the initial effort on the research and engineer side work. This slide I'm showing how we do the synthetic data. So when we do the synthetic data, right, we try to simulation how human being understand the knowledge and also label the data. First, even as human being, right, if you want to do something, you need to have the good knowledge. You need to know that data well. But you cannot remember all the knowledge. So which means you need to give the knowledge to by chunks. But if you need that, right, the human being can retrieve or ranking based on chunk, which I need to use. Since you have the knowledge, right, then it will be for the different audience. The question could be different. This, especially we do the agent, right, on the different persona use case, the query could be totally different. We need to ask the right question. For example, right, if the agent target use case is support engineer versus the agent target user is a research scientist, the query would be totally different. So if you see here, right, in the diagram, the number 1, number 5, number 2, this is related with how we do the knowledge. The number 4 side is how we do the query. Another thing we did good on the query. If someone can tell you, okay, this is the query my company wants, so we can also do the sampling based on this distribution of seed queries. So this will also help us to accelerate the synthetic query generation. So right now we have the query and knowledge. You have both, right? Then we leverage the good teacher model. We can generate the good teacher response. But sometimes we feel, even as human being, right? Someone asks me a question, I give the answer. Even I'm the domain expertise. the answer I feel is perfect doesn't mean it's real good. So we need a way to do the filter. So we need to filter the low quality answers. So finally, we have the final data set. So it's surprising to us, right? Our synthetic data is even outperforming our human label data. So we did several domains across the semiconductor, finance, and legal. So we saw the model score is leaving around 6 to 70%. There's a lot of training optimization, but here I only want to focus on the LoRa side. I don't want to focus on like tensor parallelism, how do the communication, how people do the network. So on the LoRa side, right, if we just see the diagram, right, it's pretty straightforward. You have the frozen weight. When you do the training, right, you have two metrics, but each metric, the inner side, that's the low ranking is a much smaller dimension. So which means it's good. When we do the training side, we spend huge memory in the optimum stage, especially you are using the ADAM, right? You have the original weight, you have the first momentum, second momentum, and also your gradient side. So we can save this memory, only use tiny amount of memory. So we can save around 80% of memory. On the training side, to be honest, on the feed-forward side, right, it's slightly low because you have this LoRa part is some cost, but it's not that big. But we save a lot when we do the backward. Input you cannot save, but on the weight side, we only can do on this LoRa weight. Another benefit is on the serving side. So we can serve multiple 10 out of LoRa. In our practice, right, even the one NVIDIA H100 host have 8 chips, right? We can serving thousands of LoRa's. And with each LoRa, the model size is much smaller. Usually it's around 1% of original model. It's fast loading and also transfer this weight. Here I share some best practice for our use case. So do this LoRa for the attention and MLP layer. Don't do that for the IM head or embedding layer. First, it don't save a lot of cost. Second, you will see the large accuracy drop. On the ranking side, I would say the sweet spot will be either use 64 or 128. If you want to use high ranking, right, your model weight will be much larger. If you want to use a smaller one like 32, that could be an accuracy drop. On the data side, right, depending on use case, could be the 2000 or to 10K. Yeah, this slide I go to the challenge on the RL side. Especially we do RL is very early, around February this year, right? At that time, RL Infra is not ready. So a lot of open source, they don't support the tool or multiple turn support, and the job could harden there. So at that time, since we are doing the tuning, right, so there's a lot of timeout on the tool reliability side. We could see the rate limit error for the external API or bunch of other 500 errors there. Also, the rollout is very costly, especially we are doing the multiple turn and the tool usage. Another costly is the long content length, especially you go to 100K or 1 million. This is the infra challenge. Also, there's a lot of research challenge. The first research challenge is about still related with data, also related with evaluation. How can we find the good training batch size? And also on the eval side, how can we find the reliable eval, the sufficient large eval? How can we do the stable passkey? Also, another challenge on the research side is about the agent and environment. How can we design the agent so RL can learn it? If we design agent is very stable, we don't need the RL. And when we design the agent environment, especially you work with tools usage, there's a lot of error and failure. How can we do this recover? Last one, it will be something like reward and credit. So always, especially you do the multiple tuning, right? You will have outcome, but meanwhile you have each step you have the process reward. How can we avoid the reward collapsing and also sometimes reward could hacking? Yeah, this slide I show how we do the production-ready RL training. First, on the infra side, as even I mentioned before, right, we love open source. Earlier this year, Vero don't have this multiple turn and tool support, especially in the February. So we focus version, we enable this multiple turn and tool support with our own code. And another one is, okay, since you do the single training, right, you waste a lot of resources to wait either rollout or training side. We can tolerate like a one-step gap, so we do asynchronous training. Tool server have a lot of error, or even you can have a traffic spike. So we do auto scale our tool server. So that is, we do also enable the context parallelism there to solve the long context issue. we also did a lot of effort to the tracing the metrics monitor and to do this auto recover to either the tooling side or the IL training side. On the research side, right, we already play with a lot of synthetic data. So we plug in with our synthetic data pipeline. So we have the larger training batch side, also larger reliable eval set. On the agent side, right, we learn lesson to design your agent is more complex and more dynamic. Then RL have a way to learn, okay, what would be the good practice there. And we learn another lesson. Yeah, research, they are smart, but research could spend a lot of effort to fix just like the infra error or recovery, to let the infra people or research engineer to handle all those tools error or infra related. For the reward and credit side, we chose something like in middle. So we combine both outcome and process reward there. And especially for the reward class, right? At that time, we use the GRPO is on the synchron level. So later we borrow the GSPO idea to do the synchron level reward, but with the length normalization there. On the reward side, we also leverage our in-house model, LM unit, to generate the reward signal. Yeah, this slide I'm talking about the company Inference stack. So here, if we from the bottom right, we have the model layer, we have engine layer, we have production layer. I ignore the hardware layer. Of course, there's a lot of talk on the hardware, chips, memory, or network side, but I'm more focused on the software side. So let's see the model layer, right? We have the in-house training model. We also have the open source model. So we have model from the different size and the different type from vision language embedding reward or LM. So all those models were there. We also needed to do the quantization based on the chips, right? H100, we do LP8 quantization. For the B200, we do the LP4 quantization. On the engine layer, right, that is the open source layer area, like VLM or SG-Lang. But sometimes the open source cannot solve all the problems. So we need a customer optimization. For example, Reranker, we do have our customer logic processor there. And if needed, right, for some model, we need write our own kernel there. On the production layer, there we do have our in-house solution. So this is purely our in-house solution. We build from zero. And also last year, right, not like this year. This year you have a lot of open solution like LMD, Dynamo, those solutions. But last year there's almost nothing there. So we build everything from ground up. So this layer, it gets the model ID, get a request. It will route to the different inference cluster. We have the multiple model there. If traffic spike, right, we have a way can auto scale. When traffic is light, we also have a way need to scale down. And since we do a lot of LoRa tuning, we have the way we need to manage all those LoRa, especially the scaling. Okay, where the LoRa to move with chips, we need a central place to remember all those LoRa models. For some model, the optimization on the pre-fill serving versus decode serving could be different. We also support the discrete serving. And the right side, right, this is the production ready. We need to focus, okay, the latency, the key metrics, and the error rate, and also the token. So the purpose for these key metrics, right, is even we are doing the 3.9 or 5.9 reliability, it still have the chance have incident. We want a rapid incident response and also debugging. For this slide, I would say most companies will face this issue. So when we do the infra and the model, there's multiple choice. First, I'm talking about on the training and the inference side. For the big company, yeah, most training and the inference team, they are totally separate team. Of course, they are the same org, but on the people who work on that could be the total different person. But for the startup, do we need that? Because a lot of things can sharing on the training and inference side, especially those parallelism, and especially right now, a lot of effort on the IL side, a lot of, especially rule out side is related with the inference. Another one is about the infra side, is about, okay, should we build our own, should we buy? So there is the in-house solution, there's open source, you can also custom open source. And also there's third-party solution, I pay money, just get what I need. So in Contextual AI, right, we do based by case, there is no silver bullet that can solve everything. So like on the production inference layer, right, we have our in-house solution. But on the engine layer or the training side, we do leverage open source, but we customize this open source. For some metrics, we did leverage the third-party solutions. Another one is the model strategy. So this could related balance between the research quality, safety, cost, and velocity. So models, similar things. We have an in-house model. You could call the third API. That could be the open source models. It's still based on the case, right? Doesn't matter how good a third-party OpenAI. If we have a customer, okay, we must run the model in the VPC. No network outside. You have to use your in-house model or open source model. But in general, the first experiment you can try with third-party API. Later, try to optimize the open source model with the in-house training model. Yeah. So this one I'm talking about. Before is kind of interesting area. Our training side, we do have Slurm. Our inference side, we do have Ray plus Kubernetes. For quite a while, right? We cannot share the resource. There is a high maintenance overhead. The people who maintain the training side versus the people who maintain the inference are totally different people. Especially you do the Slurm, our infra, you can only do the node level provision. But sometimes we only need a chip level. There is a observability issue or could be something debugging issue with Slurm. And also, with RL, right, we need to have the re-Slurm adapter for that. It works, but do we really need that? Also, the low development velocity. The people who do the training need to learn how to do the inference. So we migration the Slurm to Ray plus Kubernetes. So after that, right, we get a lot of benefit. The number one benefit is we can leverage the GPU on the training side. We do have the skill with DWS. DWS is good. You don't need to sign on 3 years contract. You can use the resource when you buy that, buy hourly, pay only hourly. But at the whole time, everyone needs chips. You cannot have the resource, which means put your business in the risk. If customer cannot access your model, this is a very bad customer experience. With this training resource, right, we can borrow the training side. Even training shutdown is matter, but it only matters the internal side. Customer always bigger than the internal research and users. It's also very low maintenance overhead. So we have the unified maintenance from training and inference. We can do the per chip provision. So it's better debugging, observability there, and also it's very native RL training support. And also very easy for the multiple tenor support and also develop velocity. The last one, this is the last one. So our company, we are aggressive hiring. We are hiring from the different org, from research side, infra side, full stack security, or even context engineer. Yeah. Thank you, everyone.